The wastegate controls maximum boost pressure. It does this by opening to reduce the exhaust gas flow through the turbine by wasting it directly into the exhaust system. This slows the turbocharger down, limiting the maximum output from the impeller to between 0.8 and 0.9 bar. There are two different methods of operating the wastegate, one by boost pressure and one by exhaust gas pressure and depression. We'll look at the exhaust gas one first. It operates like this. At idle, lower and medium part throttle openings, the spring keeps the valve closed. Between the spring and the valve is an operating piston and diaphragm. Exhaust pressure is applied to the valve side of the diaphragm and depression to the spring side. Once the engine speed is above 3,000 RPM, that is, the upper to full throttle range, the boost pressure builds up rapidly to 0.8 bar. The exhaust pressure acts directly against the head of the valve and, via a pipe, onto the valve side of the diaphragm, partially opening the valve. This reduces the boost pressure to approximately 0.6 bar. As the engine speed increases further, the gas flow and pressure also increase, and the valve continues to open. To ensure that the valve opens still further at an appropriate speed to prevent the engine from pinking, the diaphragm movement is assisted by depression, which is channeled via a flexible hose from in front of the impeller, where the depression is created by the increased speed of the intake air. The combination of exhaust pressure and depression ensures that the boost pressure is maintained at the optimum figure of approximately 0.6 bar. The function of the boost pressure operated version of the wastegate is exactly the same, but the operational characteristics differ in the following way. Firstly, the spring chamber is now open to atmospheric pressure via a short piece of hose. Secondly, the only operational chamber is the one on the valve side of the diaphragm, which is now operated by boost pressure. It works like this. Once the engine speed reaches 3,000 RPM, the exhaust pressure acting on the head of the valve and the boost pressure acting on the diaphragm open the wastegate and relieve the initial build-up of inlet manifold boost pressure. As the engine speed increases, the greater volume of exhaust gas flow and the now stabilized boost pressure fully open the wastegate, maintaining the inlet manifold boost pressure within the desired values. The use of boost pressure to operate the wastegate instead of exhaust gas pressure has the advantage that it cannot carbon up and reduce the efficiency of the wastegate. If the wastegate should fail to open, the boost pressure would continue to increase to a point where engine damage would occur. This is prevented by the overboost safety switch, which will limit excessive boost pressure to approximately 1.2 bar. There are two methods of doing this. The early version is a mechanical switch, and the later version is electronically controlled. The mechanical boost pressure operated switch is situated in a bypass hose attached to the inlet manifold at the rear of the engine. When the boost pressure is below 1.2 bar, the switch contacts are closed, which provides the earth for the fuel pump relay. When the boost pressure exceeds 1.2 bar, the switch contacts are opened and the earth for the fuel pump relay is interrupted. As a result, the fuel pump is switched off, engine output is interrupted, boost pressure drops, and so the switch closes again and normal operation is resumed. The electronic version limits the engine's maximum speed to 4,000 RPM by causing a misfire. The operation of the electronic unit is explained in the training video program Ignition Systems. On turbo diesel engines, this task is performed by a dump valve, which is designed to open at a predetermined pressure.